Good morning, everyone. I am B. Sangeetha working in a department of CSE IoT in SNS College of Technology. Today, we are going to see demand paging in operating system. Okay, in this video, we will be understanding what is demand paging, how it works, page fault, performance impact, and the important page replacements algorithm. Let's get started. Demand paging is a memory management technique used in virtual memory. Instead of loading the entire programs into the memory at once, the required pages are loaded when needed. Um, Instead of only the required pages are loaded when needed. This helps in reducing the memory usage, improving the system efficiency. Think of it like this: you don't carry entire textbook to the study one chapter. You only open the page you need. Page fault concept. Now, what happens if the required page is not in memory? The situation is called page fault. Steps: CPU requests a page. Page is not in a memory. OS passes the execution, fetches the pages from the disk, update the page table, and resumes the execution. This process is completely transparent to the user. Next, we are going to see about pure demand paging. In pure demand paging, no pages are loaded initially. Pages are loaded only when needed. Advantage of pure demand paging is saves money. Disadvantages is too many page fault may occur, lead to the performance issue. Working process. Let's understand with an example. Suppose the process has a pages P0, P1, P2, P3, but only P1 and the P3 are in the memory. Now, if CPU see here, only P1, P3 and P3 and P1 are in the main memory. So, if CPU requests the P2 from the disk, it updates the page table execution continuously. If the memory is full, the OS replaces an existing page under the page replacement algorithm. Finally, when the process ends, the memory is free and the page table is clean. Next, the performance impact. Demand paging improves the performance by using the less memory, allowing multiple programs to run, but the problems occurs when too many page fault happens, frequently swapping occurs. This leads to the crashing, system shutdown. The page replacement algorithm. To manage the memory efficiency, OS uses the algorithm first in, first out. Oldest page removed, simply but inefficient sometimes. Next one is least recently used. Removes removes least used page. Remove efficient but complex. Next one is least frequently used, removes least accessed page. And next one is most recently used, removes recently used page. Next one is random, removes any page randomly. Each algorithm tries to reduce the page fault. So in this video, we have seen about what is demand paging and how it works and what are all the algorithm we are using and what is page fault and how the performance impacts. So hope you all enjoyed this video. In conclusions, um, demand paging loads pages only when needed, reduce the memory usage, improve multitasking, but may cause performance issue if not handled properly. Understanding this concept is very important for operating system and real world memory management. Thank you.